Hello. It's nice to see many of you again. And so I'm Debra Golffarb, and I work for Intel, the company that a lot of people like to talk about. Mark was a great setup for this discussion because I spend my life doing exactly the 90%. So within a company that thinks about operationalizing performance, they often forget about why people write checks. And that's what I pay attention to. So I look at markets and customers and segments and diffusion and why people want to buy one thing over the next. And from a startup standpoint, often very involved in identifying those early stage segments that matter or will matter, and start building the case of why we need to start looking at certain companies or certain technologies or certain segments earlier than others. So 2 minutes about me. So I am an anomaly in this market. This is my 26th supercomputing. Yes, I missed 3. 2 because I was pregnant with my children, and 1 because on the way to Denver after 9/11 there was a gigantic crash in New York, and I was flying out of New York, and they were concerned that something was going on, and I said, you know what? I'm not going to supercomputing this year. And I got in the car and went home. So those were the 3 I missed. So I started out, I have a master's degree in Chinese studies, and learned a lot about politics and security studies, which is how at IDC I landed a job in starting their practice in supercomputing. I knew nothing about technology, but I knew about security studies and wargaming, and so I talked myself into a job, and it was an amazing journey from there. So I was at IDC for 17 years, started a bunch of stuff, including the IDC HPC user forum, and was deeply involved in a lot of policy stuff very early on in DC, trying to make the case that supercomputing mattered, and gave a voice to an industry that was mostly a bunch of defense guys and security guys, that this idea of innovation economics. And so it was the early stages of that conversation, and it's been really an amazing ride. From there, IBM recruited me, and I ran strategy for their deep computing organization, and we did a lot of cool things there. We brought out Blue Gene and a bunch of stuff, and it was, I learned a lot. Went to Microsoft and was part of their incredible technical computing initiative until they blew us up. Everything went up into Azure, and that was wonderful and sad. But Intel had been knocking for a long time. I call it the longest courtship outside of my husband. And I've been at Intel for the last 5 or so years. And I call it the Holy Trinity. I learned a lot at each of these places. A lot about how products enter markets, how software rhythms are different than hardware, and how you innovate in large companies, either sort of within a company or from the outside in through acquisition or strategic investment. So what we're going to talk about today, though, is an area that is really hot right now, which is around deep and machine learning. And AI. You've seen a lot of news that Intel is the AI company. But it actually, this journey, for those of us who've been in HPC for a long time, I think we've been talking about machine and deep learning and AI for about 2 decades, maybe longer. What's different now, and why is HPC really important to the deep and machine learning conversation? And so we're going to take a look at some things that we're thinking about. So we're going to look at the market structure. What's really driving the market right now? There's a lot of interesting things going on at the VC level, and we pay attention to that a lot. We've made a bunch of important acquisitions lately over the past couple of years in this space. And then we're going to look at where is adoption today. There's a lot of hype. What's really happening? Where is traction and why? Then we're going to take a quick look at what's next, some things that we're thinking about, particularly around algorithms and different kinds of innovation in platform, and then just some final thoughts. Okay? So Diane Bryan has been very clear, as has BK, that AI matters, and we see the sort of the integration of sort of intelligence and cognition into lots of things is going to become the norm, not the outliers. It will be asymmetrical, that's for sure, and as far as how it evolves for a variety of reasons. But this is not in my opinion, sort of analyst speak, if so to speak. This is a foregone conclusion, and part of the reason why is there's some dynamics, technology trends which we'll look at, but the volumes of data have become so enormous that you have to find different interfaces to abstract it, and cognitive models, whether it's NLP or computer vision or other kinds of interfaces, become the only way to translate and to be able to sort of consume and deal. So there are just human-machine interface kinds of issues that become pretty fundamental to this. So we talk about sort of all of these things under this umbrella of AI or advanced analytics, and we nest a bunch of stuff. This is my egg. We nest a bunch of stuff, and these definitions seem to kind of swing all over, but very simply, AI, is kind of the uber structure around these things, and it's, ultimately there's this kind of extension of human technology and computers, right? So there's this extension around technology that it's almost indistinguishable. This is the Kurzweil thought. And I think this is a ways out, if ever, really, truthfully. But that's kind of the big audacious goal, where you have this kind of this technology extension, and then you have cognition or cognitive learning, and this is on sensing and remembering and reasoning and understanding with some human-like capability. And I think we're seeing little bits of that right now. I mean, there's a lot of hype and excitement around things like Watson, but there's lots of little things like Siri and Cortana that are really on the NLP side that are really interesting, right? And then, of course, there's a lot of energy around machine learning and deep learning, which is around how do you create, models that, again, as Mark said, why does a cat look one way and a dog look another way? And we've been in the national security space and in threat and in lots of security applications. We've been using machine learning models for a long time, and there's a lot of stuff going on there, a lot of innovation that we're very, very excited about. So also, we think the market's going to be big. I mean, we're a company in business. We never believe these numbers. We love to sort of aggregate all the analysts' numbers. These happen to be Gartner numbers. And, it's okay size today, but it's going to be big. And it's going to be big in terms of hardware, software, services, data as a service, and there's going to be a lot of innovation around this space in the next 5 to 10 years. I think what's interesting, and things that I spend a lot of my time thinking about, is what's the value pool associated with that, right? So where's money to be made today and over time, and what are going to be the natural pull-throughs, okay? So there's a lot of frameworks, Torch and Café and all these things, and they're sort of innovating around developers. Where are the value pools? Where are going to be the places where there's these what we call sort of choke points or important pivot points in the market we want to be at? And there's a lot of innovation on the hardware level too. In terms of devices, not just x86 devices, but all sorts of interesting things. We just purchased Nirvana. If you didn't see that, we're really excited about it. They're really interesting people. They're really intense people. They sit right around the corner on Jones Farm from where I sit. And they're talented, and they have a vision. So we're trying to figure out, how at a portfolio level we capitalize on all this innovation. But how does it plug into how the market's going to expand and move over the pace of time here? So, the interesting thing about these technologies is that, as I mentioned before, it's going to be very asymmetric. It's going to be asymmetric in terms of what industries adopt first and what the value proposition is around some of these industries. And we pay attention at a segment level to that diffusion, right? We don't want to be too far ahead in certain markets where there's going to be limited traction, but we want to be right there where there is high degree of attach, as we would say. So as you know, we've been making some interesting, important acquisitions: Nirvana, Saffron, Movidius. We think those are really important in terms of interface points, particularly Movidius on the vision side. On the infrastructure side, Nirvana and Saffron, we're learning a lot about what this cognitive platform, what customers really want to access, how they learn, what industry is first. And so we spend a lot of time looking at those on the bottom right part. Each of those we have deep resources around understanding where the markets are, where the technology is going, what the competition looks like, where the early stage technology and innovation is at the university level. and how do we sort of snap into that early on for those areas that are going to be longer term, and from a near term standpoint, as you've seen, with our recent acquisitions. So. What's driving this? There's a bunch of stuff driving this market. Certainly, just sort of the data spin wheel or the flywheel. There's just so much data coming off of IoT devices, off of retail SKUs. I mean, there's just a lot of data in the market right now. A lot of it is insignificant data, and we're learning. Just as a sidebar, we do a lot of research. I do in my team on IoT. And looking at volumetrics and sort of the ratios of, for instance, sensors to routers to servers, follow the bit. So a bit of data gets driven off of a self-driving car. Where does that data go? Where does it land? How much hits the network? How much stays on the edge? How much goes to this, to the cloud, et cetera? So we really try and understand those ratios because we want to understand what that world looks like, right? Where we need to be. So it's interesting because IoT, there's a lot of data driven being sort of generated, but not a lot of it actually gets back to the data center. About 5%. So why? So we try to understand that, particularly in the context of things like machine and deep learning. So if it's not going to the data center, are people going to be analyzing that data in real time at the edge? So, there's lots and lots of data. Secondarily, there's a lot of innovation just algorithmically, and Gartner talks about this algorithm economy, but notion of the evolution of algorithms, how they're solving these complex analytic problems, big deal, and we pay attention a lot to that. But that's clearly one of the big drivers, and just commoditization, hardware speed, innovation at the device level. Why is the market really at an inflection point today versus when thinking machines started out as a Lisp machine? Because all these things are kind of converging. And cloud scale also matters, even though there's a lot of machine learning that is not happening in the cloud. A lot of it's in static, on-prem, big machines in HPC, which we'll get to in a moment. So, as I mentioned, there's a bunch of trends, and some I've already mentioned about this whole idea of user experience and interfaces. But there's some behavioral things that are happening around trust and transparency, how you're providing the right kind of infrastructure to access this data, to know that it's trustworthy data. Better user experience, this idea of much more sophisticated interfaces that are cognitive in nature, being able to talk to or touch or intuit. So there's a lot of these sort of external dynamics that are happening that are really propelling the market forward. But I will say something that's that I think is one of the interesting things. If you look at the enterprise software business right now, which really accounts for a lot of money in this business, right? That's where you really want to pay attention to disruption and opportunity of you as startups. I mean, if you're SAP, if you're Computer Associates, their workloads, if you're a CRM application, if you're Microsoft Outlook, you have to look at these platforms that have enormous surface in terms of the market, and look at where machine and deep learning and these AI kinds of capabilities are going to intersect those, because there's a ton of opportunity there. And if you're an enterprise app vendor and you're not integrating advanced analytics into your workflows, either through modules or other things, you're going to be out of business in an order of 5+ years, because people are going to innovate around you. So that enterprise application space, that sort of the infusion of these sort of really highly capable analytic engines are going to become pretty foundational going forward. We expect to see a lot of innovation there. Back to just the final point about asymmetry. If you look at things like ADAS, these self-driving cars, we're excited about that. We're putting a lot of investment. We have partnerships with BMW, Toyota, and whatnot, and we're really excited about it. And people think it's tomorrow. Tesla has said all their cars are going to be self-driving. There's a lot of stuff that goes into, just the regulatory piece of this, just to start. So we're excited. We think machine and deep learning and cognitive capabilities, AI all up, is going to be fundamental to actually enabling that. Everything from computer vision to instantiating patterns when a car is driving, what's going to stay in the car as, this is known, this is anomalous, and so you want to make sure that new that new capability gets scored across all cars. It's going to be a while. So we're excited about that, but we don't expect that to be tomorrow. That's 5 years out, really, in terms of scale. But there'll be other things, like some of the OT technologies, machine to machine, that might be tomorrow, right? Or certain retail capabilities. So there's going to be certain segments of the market that are going to be really fast movers, because some of the regulatory dynamics may not be so enormous, or some of the risk profiles, or there's a high degree of return early on around optimizing operations. So if you're playing in this space, pay attention to the totality. Highly regulatory industries, they're going to take longer. Those with less regulations probably are a faster pace. Look at where the risk profile, if you get a SKU wrong at Levi's, it's different than getting a self-driving car missing, right? Missing that pattern. So if you're going to play early on where there's a high degree of affinity, but perhaps a lower risk profile. So one of the things I've built at Intel are what I call these huge sensing platforms. So we have something called Athena, which is made up of 50,000 enterprise end users, which we are constantly sensing the market across everything. You can imagine everything from what technology people care about in terms of CPU design to super far out things like machine and deep learning, artificial intelligence, how they think about elections. I mean, everything we test on this to test sensitivity of the market. We have a second panel called Pulse, which is specific to HPC users. And what's interesting is that we've been looking at both accelerators and machine and deep learning across both these patterns. And the number one workload across everything, whether it's government, large, medium, small, HPC, or security. So the hot spot that people see high degree of affinity, interest, and ROI is in the broad security applications. And this could be anything from threat detection, SIEM, spam filtering should have actually popped up into that. We should have clustered that now that I'm looking at this. But there is huge sensitivity on particularly with device proliferation, IoT. I mean, just the surface is so much more complex to secure. So everything from threat detection to actually, spam filtering. People see machine deep learning as the number one use case, and it's by significant margin. It's not like in the noise. It was collectively, it was like 68%, and the next one down was like 20. So we have interesting kind of emerging focus area for the sector. But there are big challenges, and customers are really clear about what, the actual implementation. Now, I'm putting aside CSPs, okay? The Googles, Baidu's, AWS, that are aggregating tremendous talent and skills around algorithm development and implementation schemas and all these things. Let's put those aside because they're in a unique place in the market, and they have they're faster to market. Literally they're sucking a lot of talent out of the market. I'm talking about enterprises and HPC in particular. And one of the big things that as I said, we do a lot of work here in terms of understanding customer demand. And the most sophisticated HPC users who are really aggressively down a path in this space will tell you that there's not enough data. People really underestimate the kinds of amounts of data you actually need to run real machine and deep learning models. Massive. I mean, enormous. And we're not even close, okay? As well as the size of the system to actually deploy at scale to do real training scoring at scale. The second thing is accuracy. And this gets down to skills and algorithm, which algorithms people are choosing. There is still real gaps in accuracy and the integrity of the models that are coming out. So there are some significant things that are going on in the market, things that need to be solved. So, in terms of innovation, solving some of these, how do you know if the model is accurate? Are there validation things that you can create to really understand that? The third is, if you look at the workflow for machine learning, let's just take that one. About 60% of the actual workflow goes towards data cleansing and data prep. It is not sexy. It is really manual and really grunt labor. But that's where most of the workload is. It's not really, and then you get into the training and then you get into the scoring, but that front end work, if there was a way, and customers tell us that, if you could help us reduce that part of our workflow, are there to organizational tools? Are there optimization things that we can do to like reduce the time on the data prep? But it's not sexy, right? It's not the shiny penny. But there's a real gap in the marketplace, a real screaming need to go solve that problem. So there are things right now that sort of still technically have to happen to really begin to move this market at a pace, because truthfully there's a lot of hype around this market, but there's still very much an early stage market. So let's turn now for a moment to what's going on from an M&A standpoint, which is probably a lot of what people care about here. So this is very shiny in the VC community. There's a lot of energy, and if you look at the totality of cognitive and AI and machine and deep learning, it's growing about 3x the pace of the overall VC. It's really hot, okay? And as you can see on the right-hand side, it's really early stage. It's the early round investors and sort of the early seed that really dominates. And the only reason why 2016 looks small is because that data was half year. Our expectation is that it's going to exceed 2015 in terms of total. So there's a lot of dynamics going on here. There's a lot of interest in this sector, and a lot of it, as I said, we just made a handful of acquisitions, but there's a lot of innovation out there. There's this great little company called Cognoscale that I'm in love with, and all these guys came out of Watson, and they basically create a VM, a little Watson VM, and you can attach to anything. There's just a lot of really interesting ways of scaling the deployment model of this capability. So a lot of activity, and interestingly, from an exit standpoint, most of these, a lot of early stage, but in general, these are mostly M&A. They're not exits through IPO, and you can see the data there. Very, very few, because the big, as I said, there's a handful of companies: Google, Intel, Apple, AWS, Baidu. You look at them on the right. They are sucking up GE, sucking up the talent and the skills. There's a lot of acquisitions just for basic skills. There's just not enough talent coming out of the pipeline, and from a computer science standpoint, with these capabilities. So people are buying talent. They're buying IP, and it's pretty interesting. So, a lot of the work we do is paying attention to that. Who's buying what portfolio gaps, what do we need to be doing for near-term opportunities, and then longer-term things where we know the market is kind of trending towards. And so that's, it's a lot of the work that we pay attention to. So I'm going to switch again to talking about what I call a tale of three cities when it comes to this space. As I said, the CSPs, they're the unicorns. And there'll be epic battles between Google, the bat vendors in China. Baidu is so hot in this space. They are just acquiring, sucking up talent. It's unbelievable. And Google, people talk about AWS, et cetera. Google has, they have a machine and deep learning organization that is pretty damn impressive. They're doing some amazing things. And on the right-hand side is the enterprise, and if you look at our business from an Intel standpoint, about 50% about that of our, think about the enterprise business. This is, BMW, Bank of America. This is sort of the heart and soul of the enterprise. And then HPC. So I have HPC highlighted. Why? So in the enterprise space, actually, that's really weird. Adoption should be flat on the right. That's a mistake. So enterprise adoption in machine and deep learning is pretty low. It's corner cases, and it's very, very slow. And the reason it's slow is a talent issue. It's a workflow integration issue. It's a priority issue, right? So a lot of the enterprise customers are just trying to catch up on things like SDI and private clouds and refresh and moving to converged infrastructure, big data. Where this machine and deep learning fits in, yikes. Corner cases. If you are GE and you're building predicts, that's a corner case. It's an enterprise customer, machine and deep learning, really important, but I consider them an OT platform company as opposed to a traditional enterprise. So enterprise is actually slow to adopt, and we'll see that data in a minute. CSPs, again, off the board. But what's really interesting, and this has popped out of every study we've been doing for the last 2 years, is that the intersection point of HPC and machine and deep learning is an interesting one. Why? HPC is a pretty niche business, but there is a concentration of skills deep computer science expertise, high risk profile. In other words, these are often early stage companies in terms of investing in new technologies. And we knew early on, I mean, we were talking about it when I was back at IDC, the integration of big data and HPC was going to happen. It was just about when it was going to happen. So we're seeing this very, very interesting test bed in the HPC space in terms of integration at a platform level, and looking at innovative ways to build one holistic sort of big data, big compute kind of engine, what the memory hierarchies need to be, what the fabric needs to be. And so that's becoming kind of a really interesting place where we can go test things and look at how the adoption of this capability is sort of entering or diffusing in the market. So out of our Pulse study, we've been, as I said, looking at this area for the last couple of years and just some interesting data. In 2015 compared to 2016, we care a lot about longitudinality with a sample. That's why we create panels, so we know that the people who are responding are the same people, so we can look at net change over time. You can see that machine and deep learning is super important to these folks. It looks a little inverted, I just think, between somewhat important and very important from year to year, and out in the 12 to 24 month period. This is important technology. Yeah, 5 minutes, okay, for these folks. And so we know that to be true. Compare that to the enterprise, they just, there's just deep lack of awareness and ROI that they see from a technology standpoint. Doesn't mean it's not going to happen. This is from our Athena sample of much larger. This came out of our 50,000. It's down select of people who are even doing machine learning. Look how small the sample is comparatively. So we were looking at machine learning versus accelerators to see if there was correlation there, and you can see it's a much lower point of view. And and Mark was sort of good seed here. So we look at things like diffusion curves. So how does HPC look versus other technologies? So as you can see, we're looking here at HPC, cloud, and enterprise for accelerator adoption. We look at compute demand as a sort of a measurement. So as you can see in one, the current adoption of accelerators looks like, from an HPC standpoint, where it was about 5 years ago. So we look at that as a point in time. Will the market diffuse around accelerators and machine learning on a comparable basis for the enterprise? We can see cloud vendors, as noted in 2, are going crazy. They're just sucking up PHY and accelerators right now, sort of outpacing the market. And we can see in the HPC space, it's beginning to taper off a little bit in terms of the use of accelerators. We think the reason why, I think it's a conversation, this is the point of the integration of machine and deep learning. If you look at classical HPC versus what's coming up from below this machine and deep learning space, we think a lot of that new compute demand is going into those workloads and being kind of renamed. We call that implicit HPC, sort of embedded HPC, that you don't even know you're using an HPC system, but it's these machine and deep learning capabilities. So you can see as we watch the diffusion curve of this, what we're likely to see if it paces the same way. I have a few more slides, so I'll try and be very quick. We also, just to kind of sort of level set on why HPC is sort of a hotspot, we do things like job scrapes. So we want to see who's hiring what in HPC, right? What does it look like? And as you can see, we look at the totality of HPC, and then we look at a workload level. And as you can see, 50% of the jobs that are coming into HPC are around machine and deep learning. So that tells us a lot in terms of where the energy in the market is and what's going to matter. Particularly if you're hiring now, you're looking at a 2 to 5 year period where these people become kind of like instantiated in their jobs and begin to make a significant contribution at a company level. And these are mostly enterprises as opposed to university government. So these are sort of commercial enterprises hiring. So really quickly, I'll go through this and then close up. Okay, so where we are today is not the end zone. Okay, we think we're really, really early on algorithmically in terms of machine and deep learning, and this is, again, are things that we pay attention to. We're not at where the puck is skating to. We know that there's a lot of innovation that's going to happen, and so we look at kind of this notion of the master algorithm concept of tribes of the types of algorithms that got created. And today, mostly the market, as you can see, is on the left. And this is around this notion of connectionness. And, but the whole right side are things that really look at different types of analytics and deduction. And there's early innovation in these spaces. As you can see, there's a lot of academic research, very few, few commercially available kinds of technologies. And so, what do we need to do as a company to kind of really innovate there? And there's a lot of discussion from companies such as Google and academicians who begin to think that maybe we're moving towards some holistic kind of algorithm that embraces all these different kinds of capabilities. And again, when we think about innovation and startups, we're looking there. Who's going to be innovating around those things that may really provide differentiation long term for Intel. So real quickly, just to close up, today, the market is asymmetric in terms of who's adopting and where. The CSPs are way out in front just by virtue of their scale and what they see the true market opportunity. Enterprises follow, but HPC is a very, very interesting place of innovation and an intersection point and may really be the test bed for a lot of these enterprise apps. We think that there's going to be a whole bunch of new use cases, ADAS, video analytics, retail, healthcare. There will be bumps and starts. If you're innovating, if you want to be in this market, you may have a long-term vision. You want to be the company for predictive medicine, precision medicine, but you have to make money today. So you have to look at those markets that are going to evolve earlier than later so you can begin to get traction. Follow the money in terms of where the value pools are in this market. Look where the venture guys are investing. Look where the gaps are in the market. Get your footprint there in terms of look at where these real openings are in terms of requirements in the market that aren't being met. And know that we really just have begun. I mean, we're really still at the very, if you think about a diffusion curve or an S curve, we're sitting here in terms of where this market could go in terms of scale. And there are dependencies in terms of IoT and other big areas that are going to sort of co-evolve, that are going to be kind of who the driver or the drafter is. Thank you very much.